Hi everyone. Today I'll be presenting my project on detecting fake job postings using machine learning. I'll give a brief introduction and the problem that we are trying to solve and the system overview, our approach and methodology that we have come up with, and evaluation metrics that we are using to evaluate the model and the results. And since we are using different models for this problem, we have done a brief model comparison and we are going to conclude with the results. Let me give a brief introduction. With the growing reliance on online job portals, the number of fraudulent job listings has unfortunately increased. Scammers often disguise fake jobs to steal personal data, demand upfront payments, or lure job seekers into unsafe situations. Hence, this project aims to use machine learning, specifically natural language processing, to identify and flag such fake listings before they harm anyone. I'll walk you through the background, the system we have developed, the methodology, including the code and how well it worked. Fake job scams are a growing concern. According to recent reports, Americans lose hundreds of millions of dollars every year to these scams. Unlike spam emails, fake jobs posts can look very convincing as they mimic real job ads and often use professional sounding language. The challenge lies in the fact that the data set is heavily imbalanced. Most of the job postings are real and only a small fraction are fake. So, our model needs to be smart enough to detect subtle patterns in the text that might signal fraud. So, this makes it a classic case for binary classification, but with the added challenge of imbalance, which we'll deal with it using a technique called SMOOT, which produces new synthetic data. So we are using a Kaggle data set which has around 18,000 job postings, and the features included are title, location, department, salary range, description requirements. And the challenges, as I mentioned before, is unbalanced data set. So we are going to start with our system involves several stages such as process the job description, such as cleaning the text, removing the stop words. Then we are going to vectorize the text using term frequency to convert it to numerical features. After that, we apply SMOT to generate synthetic data to balance the classes in the training data. Next, we build classification models such as logistic regression support, vector machine, and random forest. We train them, make predictions, and evaluate their performance using multiple metrics beyond just accuracy. To evaluate the model, we didn't rely only on the accuracy. Since the data is imbalanced, a model could achieve some 90% accuracy by predicting every job as real. So we use these metrics, precision of the jobs predicted as fake, how many were actually fake, and recall of the actual fake jobs, how many did we correctly predict. And mean of the precision recall is F1 score, and confusion matrix gives us a detailed look into true positives and false positives, etc. So also area under the curve, a single value that summarizes the model performance across all classification thresholds. We also plotted the ROC curve to visualize how well the model distinguishes between real and fake postings. So these are the three area under the curve graphs for three algorithms. First one is logistic regression where we have got 0.93 area under the curve, and for random forest it is almost near as 0.98, and same as support vector machine. The results we have got for three models, accuracy was above 97 for all, but let's take a deeper look. For logistic regression, the precision was around 0.87, but recall only 0.48, so it missed many fake jobs. Support vector machine looks best because of the precision 0.80 and recall with 0.86 and F1 with 0.83 and random forest with the highest precision, but the recall was slightly lower than support vector machine. The confusion matrix confirmed that these insights. So for example, support vector machine correctly identified 131 fake jobs and only missed 22. The area under the curve scores were also high. For logistic regression, it's 0.93, and support vector machine, it is almost equal as 0.98, almost near to 1. Hence, we can conclude that support vector machine was our top performer overall. To summarize the comparison, support vector machine had the best performance with the highest recall and area under the curve. It's excellent at catching most of the fake jobs. Random forest had the highest precision, meaning when it says a job is fake, it's likely to be fake. Logistic regression had good accuracy but failed in recall, which means it missed a lot of scams. This shows the importance of looking at multiple metrics, not just accuracy, especially in real world problems where the cost of misclassification can be high. So, to wrap up, fake job postings are a serious growing threat, and machine learning offers scalable solution. We use text vectorization, class balancing, and multiple models to train our system. Support vector machine emerged as a most balanced model, combining strong recall with good accuracy and a high ROC AUC curve. By focusing on precision recall, we ensure that we don't just get good numbers but real effectiveness, helping people to avoid falling for scams. Let me briefly go through the code. This is our notebook where we have imported all the modules that we are using in this project. We are mostly using scikit-learn package to import all the machine learning algorithms as well as the evaluation metrics. And here is the dataset view uh, without pre-processing, where we can see the title, location, department, salary range, and all the fields that is present in the data set. So these are the column names. We have done a brief data analysis to understand what kind of data set we are dealing with it so that we can handle the imbalance or bias, to remove the bias in the models. So first, we started with plotting the heat map to understand the description of the data set, where we can see what are the most jobs that are present, and those jobs are present from which industry. So here we can see most jobs are present from information technology and services and lesser from the legal services. And this is the word distribution among the job description, where most number of jobs were for manager, developer, and less were for business specialist and accountant. So these were the most common words that were used in the data set, and when we are trying to plot between the fraudulent and non-fraudulent, so this data set has 90% of non-fraudulent jobs and only 4% has fraudulent. So it's very likely that when this data set is given as it is without any modification, our model is going to be biased and our model is going to predict most of the jobs as non-fraudulent itself, but our main focus is to detect both fraudulent and non-fraudulent as it is without any bias. We are combining all the text data into one column, and then because it is easy to vectorize, this is just word cloud. It just gives what kind of description and what is the most common words that is being used. After we have combined the description and we have created the dummies for all the other fields, and this is where we have we have leveraged the NLP to remove the stop words from the description and tokenize the words and then process the text. After we have processed, we are going to divide the data set as 80-20 percentage and then vectorize it, as we are going to convert the text into vectors, and then use mode technique where we are going to create synthetic using this technique it is going to create synthetic samples. You can see from the output there are 14,000 and 3,000, which is highly imbalanced. Hence, we are going to imbalance between the train and test. So we have to create synthetic samples so that the dimensions of the data set of both train and test match. So after we have created, this is the dimensions, and then run the logistic regression. So this is the confusion matrix for logistic regression and classification report, area under the curve. Similarly, there was one challenge when we were trying to run with the same data set and same sampling technique for support vector machine, where we are using minimum and maximum feature as 5 and 0.8 and 1 2 n-grams, but previously it was more. For logistic regression, it was between 0 to 1, and it was taking longer to run, and even after many hours it did not execute. So I I changed the parameters so that we have a new data, new sampling, and then use the same technique to or oversample, and then again resample with these n samples 5,000. So it is simpler for SVM to handle. So after that, I was able to run this successfully, and this is the confusion matrix, and this is the area under the curve. It is almost touching the y-axis. So this is the random forest output, and this is the area under the curve for the random forest. So this is our code, and yes, and this is our project. Thank you for your time. Thank you for listening.